Hey guys, so we are starting day 2 of Unit 4. Still all in the motion category, okay? So today we're gonna still connect velocity. When is velocity increasing? When is the speed increasing? What's the difference between displacement and total distance? And those are the things we want to focus on here. So we have talked a lot about these, so you should know this, hopefully. Okay, you've got this down already. What speed is, position, velocity, acceleration, how they are related. If you want to go over that more with me, let me know. Okay, so here's a graph of velocity. So velocity, and then probably just whatever the time is, okay? Because it said v of t. So if this is my velocity, how would I sketch a graph of speed? So to sketch the graph of speed, remember everything is absolute value of velocity. So basically, I'm just going to flip everything that was underneath up. So here at the 5, I'd be at the 6, and that little line, and then back down to the 9. Okay, so this right here stays. This is now flipped up. And this part right here stays because it was already positive. So the purple would be my velocity graph. So here it says where is speed increase, or sorry, the purple would be my speed graph. So where is speed increasing? Speed is increasing here and here. So what am I going to do? Let's see, speed, part B, increasing from 3 to 4 and from 9 to 11. So what do we notice about those intervals back here now? I was to get rid of all this and just look at the v of t graph. So this was my v of t graph. What do I notice about the interval from 3 to 4 and from 9 to 11? What is happening? Well, I can see that on v of t, as time is increasing, v of t is moving away from the x-axis. Okay? So now we're going to go to D, trying to connect a lot of this. Now it wants me to sketch the graph of A of t, and remember A of t is V prime of t. So we are going from 0 to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know why I put those numbers, just did. And I'm going to go up to, let's see, 3 on here, 2, 3, and down to negative 3. And we'll discuss why here in a second. So now if I'm going to do v prime of t, this is t. This would now be my a of t. Okay. So now we remember that denominator has a squared in the units label. And I want to sketch that graph. Well, this is nice and easy because all of these are linear, so I just need to go find the slopes of these. So the slope is 0, this is down 3 over 1, the slope is 0, and what's the slope? Up 6 over 3, so that would give me a, did I just do that right? Up 6, 1, 2, so this would give me a slope of 3. Okay, so now I want to just make sure I did that right. Up 4 over, no, I did that wrong, didn't I? That's a slope of 2. Up 6, 1, 2, 3. Oh, 6 divided by 3 is 2. Hard math there. Okay, so now I have all of those slopes. So now I know, and remember at those edges, here, 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 we are not differentiable. So we're going to have open circles on the A of t. So from time 0 to 2, I am at the 0. Then from time, if I look up there, 3 to 5, I am at negative 3. No, not 3 to 5. 2. 2 to 5, I am at negative 3. 2, 5. And then from 5 to 6, we are back at 0. And then from 6 to 11, we were at 2. Okay, so now we can have this graph of A of t. And now I want us to kind of compare. Let me see if I can make this a little bit smaller now. I want to compare these graphs and what we knew about speed. I'm going to erase all this for now so we can kind of just look at these two graphs. So on those intervals from 3 to 4, so I'm going to look at this 3 to 4 and look at this 3 to 4. And then also on this 9 to 11 and on this 9 to 11. And what do we notice is happening on those things right here? Well, it is where we have the same sign. So this is part E. So when V of t and A of t have the same sign, then speed is increasing. So if we notice, up here by same sign is positive, down here is negative. Up here is positive, down here is negative. So basically, what we're saying is if V of t and A of t are both negative or both positive, that is when speed is increasing. And if I have V of t and A of t with opposite signs, so I could have negative positive or positive negative, that's when speed is decreasing. So we have lots of options to talk about when speed is increasing. One is what I just said, okay? Speed is increasing when V of t and A of t have the same sign. Two, when I went and graphed at the very beginning, the speed graph has a positive slope. 3, if I just looked at the V of t graph, I would look where V of t is moving away from the x-axis. So we have several options to pick from of when speed can be increasing. And it just depends on the problem to know, well, what do you want to do? Oh, shoot. So let's go look at the next problem. And you get to use a graphing calculator. And I'm going to get a different highlighter because that one's kind of ugly. No, you ugly. All right. A graphing calculator question. A particle moves along a straight line. Our t is between 0 and 5. And here is the velocity function. It's also known that s of 0 equals 10. This, you guys, we're not going to get to that piece and need it until we get to integrals. So, okay, thanks for telling me for now. Says find all values in this interval for which the speed of the particle is 2. This is a review. We have practiced this a lot, but let's see if we remember what we do for this. Speed is the absolute value of velocity. and I want to know where does that equal to? Well, if you remember, what I liked to do was subtract it over and set it equal to 0 and go look on your graphing calculator. And we're only going to look, it says, from 2 to 4. So as I set up my window, I'm going to look between 2 and 4, and I'm not going to go down very far, maybe like -1 and 1, so that I can find where it's going to cross. This one actually crosses at 2 spots. I don't know if that's the graph or if it goes like this, I don't remember. But it crosses at 2 spots, and we need to find those t's. Go see if you can find them, and we are going to check in class. Ha ha ha. So make sure you find them and then ask me in class if you got them right. Okay, so now part B, this is the newer piece. Is the speed increasing or decreasing at t equals 4? So now you have some options, okay? I'm going to go with that first one that we had, and I'm going to go ahead and use my, okay. I'm going to use my Math 8 to find a of 4. And when I did that, I got that that was a negative answer. Then I'm going to look and see, well, what is v of 4? So we can plug that into the original. And v of 4 is also a negative answer. Notice how I do not have to put what they are. I just need to know if they are less than 0 or greater than 0. So once I know that, I can say that speed, therefore speed is increasing at t equals 4. That is my favorite way to do it. You could have also done one of the other 2 ways on this one. This particular question would let us use all 3 ways. So whichever you felt most comfortable with. Some questions won't give me more options like that. Okay, so let's look at this next one. Here is the graph of a position function. So t is in seconds, position is in inches. And it says the position is moving along a horizontal coordinate axis. Let's think the x-axis, like that little yellow ball we discussed before. When is the particle moving to the left? So I know I'm going to be moving to the left when v of t is less than 0. So that's the same as when we are saying when s of t has a negative slope. So when does that guy have a negative slope? Negative, and I think that was supposed to be a constant there, yeah. So the only place that we have a negative slope is on the interval from 2 to 4. B, when is the particle moving to the right? That's going to be when v of t is positive, i.e. when s of t has a positive slope. And where does that occur? Only right here from the time interval 4 to 6. When is the particle standing still? That's when v of t is 0, or when s of t has a 0 slope. And where does that happen? 0 to 2 and 6 to 7. And lastly, when is the particle moving the fastest? Well, we are moving the fastest when speed is the biggest. So if I look at this, this gave me the position function. So the first thing I'm going to do is find all these slopes and make a velocity function. So I'm going to make it in purple. So this guy has a slope of 0, not differentiable at these edges. This has a slope of 1, 2, 3, 4, 1, 2. So, hold on. Oh no, this goes by 4s. 2, 4, 6, 8. 8 divided by 2 is -4. Up to over 2, 1, and 0. So that would be v of t. So now if I wanted the absolute value of v of t, which is the speed, this is going to stay. This now goes up here. This is going to stay, and this is going to stay. So where's speed? The biggest value right here is the biggest value of 4, and that's on the time interval from 2 to 4. Okay. Okay. Next one. I want you guys to actually try this and see if you get the right answers. I'm going to give you the answers so you can pause me and then check them, okay? And make sure you understand why. Don't just write what I have, or that's not going to help you. And see if you get those out. If not, then ask me for help and I will help you. Okay, next one. We're going to talk about displacement versus total distance. So we're going to use that with this little honeybee example. Isn't it cute? So a honeybee makes several trips from the hive to a flower garden. The velocity graph is shown below. So it looks like this is in minutes and feet per minute. So this is my velocity graph. And my question is, what's the total distance traveled by the bee and what's the displacement of the bee? What is the position of the bee at the end, after from 0 to t minutes? So after 10, sorry, not t, after 10 minutes. Okay. So this area, this is going to be kind of a newer concept that we will talk about, is giving me, so the area of this, see how they're telling me what they are? This is giving me how much the bee has traveled, okay? So when I take this, if you kind of see, this 100 feet per minute, and I multiply by the 2, and this is now in minutes, the minutes now cancel, and I get 200 feet. So that 200 feet is giving me the distance that the bee has covered. Since it's up here and it is positive, then I know that he is kind of like going from the flower like in one direction in a positive direction. He went a positive 200. Then down here, this 200 is actually a negative, so it's like, okay, now he's going back 200. Then it says he's going to go forward again 200. And then it says he's going to go back 100. So that's kind of like what the bee is doing. And here I can put a negative, sorry. So the total distance that the bee has been going back and forth would be 200 plus 200 plus 200 plus 100, because he's covered that. Okay, so the total distance is like whether or not you're going forward or backwards, you're still like burning these calories and moving around. So that's my total distance. So total distance here would be 700 feet because I'm adding all of them up. The displacement, though, is that it's like, where have you ended up? So see how he ended here? Right here is like where he has ended. And so we're kind of going from the 0 to this 200 back and forth and back and forth. And then he finally lands right here. So his displacement, if he went back 100, would be at 100. So he's like 100 feet away from where he initially started. So the position of the bee here, so if this is like my flower, and here's my beehive, whatever it looks like, okay, hanging from the tree. Oh, that's a horrible tree. Okay, so here's my beehive. He is 100 feet away from the beehive, right? So his position here is either like 100 feet closer to the hive or, like from the hive, or you could say he's 100 feet out from the flower. However you want to say it, you have some wiggle room there. That would be like where his position is. So let's get that concept of what we talked about here to find this area of being this 200 of how many feet he has traveled. And let's look at this one. So now, again, here's my velocity graph. And this would kind of, we can even think of it if it makes more sense to like say seconds and maybe like, again, feet per second. So I know that this right here, when I multiply, would just give me the feet, okay? But this is basically saying a position of 1 forward. This would be and they've already found this, so 1 times 1 divided by 2. This would be a position of 1/2 forward. This would be a position of 1/2 backwards, and this would be a position of going back 2. So the displacement from 0 to 5, have they moved forward more or have they moved backwards more? Well, we definitely have went backwards more, so I know that my displacement is going to be a negative answer. So I'm going to have this +1 and +1/2, and then I'm going to subtract the 1/2 and subtract the 2. And I can see my displacement would be from wherever I started. So like if this is where I started, and then like I went forward some, and then I went back some, my displacement would be -1 from where I started to where I ended. That's that piece. But now the total distance is saying, hey, whether you move forward or you move backwards, how much did you travel total? So that is where I'm going to add the positives and the negatives together, and I get out 4. Okay, so this next one now is a little bit different because it's starting me with a position function before we had a velocity function. So S is measured in centimeters and T is measured in seconds. So you have a few options. You may want to just look at the velocity graph first. So I'm going to go ahead and see, well, what's my velocity graph? So I'm taking the derivative here, and then I'm going to sketch my velocity graph. And it looks like I want to go from 0 up to the 6 is what I'm seeing. So from 0, at 0, I am at -3. And then I'm going up to over 3. Just slide. 1, 2, 3. So up 2 over 3. Up 2 over 1, 2. Cheating. All right, so here's my velocity graph. And this is kind of hard to see. Let's find where that's 0. See if I kind of got it in the right spot. Equals 3. So 9/2, which is 4.5. 1, 2, 3, 4. So it looks like I should have got it about right there, 4.5 is where it crossed. Okay, so next thing I'm going to go ahead and do is find these areas. So this area would be 3 times 4.5 divided by 2. And this area would be 6 minus 4.5 is 1.5 times 1 divided by 2. So let's go ahead and find those areas. Calculator. Well, we could do this by hand. I'm going to go ahead and just save time. Unless you want to do it by hand. We can. Okay, so this gives me 6.75. And this gives me 0.75. Okay, so the displacement, I know that they have moved in the negative direction way more than the positive direction. So my displacement here is this negative 6.75 plus the 0.75, which would give me a negative 6. The total distance, though, is going to be adding them together, the negative and the positive together, which would give me 7.5. Average velocity and instantaneous velocity. Go ahead and pause me and try those, and then see if you get the what I get after you unpause. And I probably should have been labeling, even though it didn't say it. Okay. And if you need help with C or D, let me know. Okay, crazy fun now. The AP example. And this one is actually a no calculator. So on part A, well, let's actually read through it. The two particles, ooh, they're moving along that x-axis. Here's particle P's position. So they're saying x is the position, particle P. And then they're giving me, ooh, the velocity. So they're saying V now, velocity of particle Q. So they're giving me two separate things. And then this piece right here is going to be for an integral piece that we'll worry about later. Okay, so for now, you just say thanks for that. A, when is particle P moving to the left? So particle P moving to the left. So think about, when do I know particle is going left? And I hope that you guys are all saying when V of t is less than 0. So I want you to actually go find that and see if you can answer when particle P is moving to the left. And I got from 0 to 1. That's a 1. I'm going to have it open or closed here. If you need help with that, let me know. B wants you to find where the particles move in the same direction. So I'm going to set up on B kind of this number line from 0 to 8 and kind of look at the velocity going on of the Q and the velocity of the P. And like, when are they positive? When are they negative? So here, we found this velocity to be negative between 0 and 1. And then everywhere else, so that was for P. So we know we have 1. So we have negative, and then everywhere else the sky is positive. So now I want to look at this Q. And I'm going to go ahead and factor that. Hopefully you guys can factor that pretty fast without me. Don't just write what I write, pause it, think through it. So I have 2 zeros, and then I just kind of need to see what's happening as I plug in values before and after the 3 and the 5. So plugging in 1, I would get positive. Plugging in 4, I would get negative, and 6 would give me positive. Okay, so now I kind of know that I'm looking at this 3 and I'm looking at this 5, and we said we went positive, negative, positive. So where are we moving in the same direction? Where are they both positive? Well, I can see that they are both positive right here from 5 to 8. And when are they both negative? I don't see, oh, I do see another place where they're both positive though. So it looks like they're only just both positive, that they are never negative at the same point. So this is from 1 to 3 and 5 to 8. And you may want to like pause that and slow it down and rewatch that little piece and make sure you understand that. Not ask me a question. And for C wants to know, is the speed of particle q increasing, decreasing, or neither at t equals 2? So here it wants just the q, and remember this is the velocity. So you have some options. You can sketch this velocity graph, find where it's going to towards or away, like from the x-axis. You could make the absolute value of this and look for a positive slope. But I'm going to go ahead and do the way that I prefer, which is to find v of 2 and see it's greater than 0. And then I'm going to go ahead and take that derivative and find a of 2 and see that it is less than 0. So now I can see that v of 2 and a of 2 have opposite signs. So speed is decreasing at time equals 2. Okay, I want you guys to try the next AP example on your own. I am going to tell you that A, you should get speed as decreasing. And on B, you should get 2.707. And make sure that you justify your answer of that. See if you can get that one. And that one was a calculator allowed. So try that one on your own. Same thing on this one. I want you to try this one on your own. This is a calculator allowed. And here, see if you get that. And on this one, and make sure that you interpret. Okay? And we can check those together in class. And I also want you to try this matching on your own. And then I'm going to give you the answers. So make sure you pause and then see if you can get to these. Take your time and like do it on your own. Don't just write what I write. This is good to practice these. Okay. And I'll see you guys soon.